Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you can tell by the title, we will be talking about a potential winter storm that could be forming into next week. Now this thing would be a rather massive system in terms of its size and scale. As you can see, I have pulled up here the GFS representation of what it thinks this system might be. Now I do want to give a fair warning, this system has a lot of models disagreeing with each other, and the reason why I haven't made a video in the past few days is I was trying to make a video about this storm, but the matter of fact is that honestly it's not often that you see models disagree as much as they are disagreeing on this system. And you may be saying, oh yeah, because it's still over a week out, 160 hours. The thing is though, we've seen models agree on systems that are 100 200 hours out, 250 hours out, with more agreements than again what the models are doing with this. So this is going to be a tricky forecast, and what also makes this a lot worse is that it's going to be occurring well at the busiest travel time of the year, around Thanksgiving. You could see if depending on which model you look at, some are introducing it as early as Wednesday, Thursday, Friday, the three biggest days of travel. And yeah, I believe Thanksgiving is more traveled on than even Christmas for at least the United States. So this would be a impactful system nonetheless. And I will also be going over briefly at the beginning of this video the extreme and impressive lake effect that is going on right now across the lakes of Erie and Ontario, and what to expect kind of from that. So I'll leave a little ticker at the bottom of this video about where to skip towards if you want to just hear me talk about the winter storm and not just the lake effect. But let's get started talking about this lake effect, as I said. So right now I was just looking at my area here, zoomed in. You can see that there are plenty of little showers, snow flurries occurring across many of these areas that aren't even affected by the Great Lakes. Further eastward, yeah, we have obviously off the lakes of Michigan, we have some pretty heavy snow, not as legendary as what we're seeing across Erie and Ontario, but you can still see there are some winter weather advisories, which are calling for 3 to 6 inches in the winter storm warnings, up to even a foot of snow, of additional snow, and across here, 4 to 10 inches of additional snow, and there have been already amounts well over a foot here. There even have been amounts over 2 feet across the northern Michigan right there. So yeah, an extremely well set up event, which is why some of these amounts, especially across Erie and Ontario, are going to be approaching historic territories. Last time we saw an event, something that compared in terms of caliber to this, was 2013, where we saw that extreme snowfall across Buffalo, where some areas got over 6 feet of snow, which could be possible by that time this thing is done with. Maybe this thing will even outperform that. And notice that, yeah, this has been deadly consistent through most of the day with extremely heavy snowfall rates, meaning 3 to 4 inches of snow per hour, which is pretty much life-threatening at that point. You could get easily stuck on a road and whatnot, and they won't have time to clear it. So yeah, really concerning. And obviously this will continue to go on overnight. Let me show you some of these snowfall amounts that are coming off all the lakes, but especially off of Lake Erie, which was the main lake that was supposed to be concerning. So obviously you can see off of Lake Superior we have some amounts that are impressive. 24 right there, Ironwood, near just north of there, 24 inches, 2 feet, obviously very impressive. Notice where the various scattered snow showers and snow flurries occurred, we also have some small accumulations of 1 to 2 inches. And obviously, as I mentioned, we have amounts over a foot here in some areas across Michigan here, and across the northern areas you can see also approaching 2 feet. Again, into Cleveland, Ohio, significant amounts, but they just get dwarfed by some of these amounts that we're seeing right here, which really is rarity to see such a high snowfall amount. Notice I'm recording this as of 6:19, right? So we are seeing a 6 o'clock Central Standard Time report out of Orchard Park, New York, 66 inches. I mean, that is hard to fathom. Most people aren't even that tall, let alone can picture that amount of snow. So yeah, that is obviously crushing amount of snow. And notice that this area has been giving us updates kind of every other hour. You could see 3 o'clock, 4 o'clock, 6 o'clock, and you can see how fast these things have been going up. 4 to 5, 6 inches of snow per hour. And you can see that Orchard Park on this map, New York, where these high amounts are reporting in from, would be right there. Notice there are some amounts, 48 inches, which report at 1 p.m., I'm assuming these areas have probably picked up 20, maybe even 30 more inches of snow from then. Well, maybe not 30, but easily 20, so there could be a 70-inch report here. Again, this will be extremely impressive to see, or extremely interesting to see how this lines up tomorrow when all these reports are going to be kind of coming in. You can see even across upstate New York that are off of Lake Ontario, also 42 inches of snow. I mean, a ridiculous snowfall event. And yes, I mean, once you start getting such amounts, it's, I guess fascinating from the meteorological aspect, but it's it's really quite deadly. And last time there was around 13 people that died. This time you could expect, well, realistically, probably something around that amount, especially since this system is, since this lake effect snow could continue still for several hours, and we are already approaching areas or amounts that we have, we saw during that 2013 event. And yeah, I mean, it's incredible. I mean, just looking at the radar, how this band just converged. I mean, we have truly Arctic air for this time of the year coming in across the United States, and with such warm waters, it's really no brainer that we would have lake effect. But obviously, you know, it takes a perfect storm to create an event like this. And yeah, again, the additional amounts of snow that are set for that area are still very impressive. I could go back and show you some of these winter advisories that were set up here. Or, sorry, these winter weather alerts, which is obviously lake effects and warning. And again, you can see there's one from Saturday 1 a.m. right there. Okay, so if you look at that, additional snow is probably 5 to 10 between just at 1 a.m. So again, if you're seeing, you know, 60, 70 inches, you could pile at least 10 to 12 inches more on that. And then there's that second alert, which is from 7 p.m. Saturday till Sunday 1 p.m. And that's an additional one where there's going to be a little clipper kind of that comes through, changes the orientation of things, but it kind of continues piling on a lake effect from a slightly different angle. Buffalo hasn't really, you know, the downtown area hasn't really seen much activity yet. I do believe it will, as these lake effects, yeah, will move north across the area. So, you know, that could easily drop 10 to 20 inches in just a matter of a few hours, you know, 5 to 6 hours. So that is that. And again, off of Lake Michigan will be continuing as well. Off Superior, you can see in Canada also decent amounts of snow. Just again, nothing really as legendary as this. So I've been kind of here sitting throughout the day, refreshing this periodically and seeing if there's, you know, any new crazy amount of snow. And every few hours there is one that just comes in, you know, 66 inches. That's ridiculous. All right, so now, you know, if you've skipped forward, this is where you've landed in a video where I'm going to start talking about that winter storm. So let's start talking about this winter storm potential. So first off, let's go to the GFS. And again, just to show you this from a global forecasting model perspective, here is those lake effect bands. You can see they're obviously pretty localized in nature. I mean, you saw area south of Buffalo seeing 60 areas, you know, in Buffalo seeing pretty much nothing as of now. And again, there's that little disturbance that will come through, shift some of these lake effect snow bands pretty much squarely towards the north, which will affect cities like Buffalo. And then notice that through Sunday, it kind of re-intensifies. Briefly, it reorients themselves a bit towards the south and east, and then they kind of stop after a while. But again, some of the snowfall amounts that could fall there are, again, at least another 2 to 3 feet possible. And you can see that what we do start seeing is a moderating pattern. We're obviously dealing with very cold air across much of the United States right now. Into the future, this will start, if you will, moderating. We'll see warm air come in, and we will see, again, that potential for that winter storm on Thanksgiving week. So, the early part of the week, very calm. Actually, very good weather for a good portion of the United States, excluding Florida, maybe portions of the Gulf states right here by the Gulf Coast, seeing some sort of rain. Notice we do see a system moving towards the northwest. Again, nothing incredible for the northwest standards. It's going to have some snow, it's going to have some rain. But what it does potentially out in the plains is what is interesting. So, notice we have a high pressure that situates itself across the eastern United States, setting up that classic setup from the south and west, those winds pumping up warm air, moisture from the Gulf of Mexico. And this thing kind of does do that, and you can see it starts spinning up a nice cold front, a nice almost you know, kind of like almost probably a blizzard. If, you know, if this were to come true, those winds would be very strong. And again, blizzard doesn't necessarily mean heavy snow, just reduced visibilities to a certain extent for a certain time period with the snow that's either falling or on the ground. And notice that this does include the GFS run on Friday. It starts developing the system, so the day after Thanksgiving, again, a busy travel day. A lot of, you know, major cities with rain or snow and cold air behind it. And you can see this does end up moving into southern Canada as a monster. Now, this is just one interpretation, and I don't really want to focus too much on this, analyzing the individual characteristics, because there are so many different interpretations of the system from so many different models. It's a little bit concerning because, well, you know, you don't really like doing that because, or we as meteorologists, I mean, not me, but as a weather enthusiast, don't like seeing this type of stuff, and meteorologists don't like seeing this type of stuff because it lowers their confidence in the forecast. You don't really know what to tell people, you know, just a few days out, maybe this thing will change into an all-rain event, maybe it just won't even ever form. There's some models that, even the GFS today, or yesterday at midnight, I believe, yeah, barely showed a system at all. It showed a northern part of that system, showed a southern part, and it just, you could see nothing. And now it's showing a stronger system, and then that showed that yesterday at midnight, right? That system that never really formed. But if you went a model or two runs prior to that, you could see it also showed a system. So the inconsistency has been really astounding and quite frankly frustrating. If you take a look at a model like the Canadian, right, I want to show you as many models as possible. There's that lake effect, there's that cold air. Again, just like the GFS, the Canadian does start moderating a lot of this cold air and starts pushing it out of here. We start seeing that high pressure setup, warm air moving to a good portion of the United States. Again, warm for this time of the year, relatively speaking. And you can see there's that little disturbance off the northwest, though it is pretty far towards the north. So it's kind of late to develop its cold front or whatnot. Even if it there's some models again that don't even show anything developing. The Canadian does show something. You can see some sort of a weak system, weak area of circulation. Maybe some snow on the backside here. Nothing too impressive, but we do see some precipitation starting to rise off the northeast coast. And you can see that by Thursday, Friday, we see some heavy rain across New York and Pennsylvania into obviously the mid-Atlantic, into portions maybe the southeast. We do see some scattered snow further out towards the west. Again, nothing too impressive, but what we do start seeing is more of an impressive system towards the north and east and portions of southeastern Canada. So that would still be an impactful winter storm. A lot of cold air behind it, though again, you can see it's just already quite a bit different from what the GFS shows. And the Canadian, of course, like other models, has been very inconsistent as well. This is the model run just from yesterday at midnight. So again, Tuesday, this is Wednesday, Thursday. There's that, moisture from the south. There's a little clipper, but there's a strong area of disconnect. Shows quite a bit of snow there across the deep southwest, and really nothing else. I mean, you can see there never really was a massive storm. So yeah, they've been inconsistent with themselves and obviously amongst each other. They've been, going back and forth pretty inconsistently. So let me now show you the European model. So let me just show you this on, weathermodels.com, United States. Let's go through these different filters here, and let me click on just the simulated radar interpretation, I guess, or it would be the 6-hour preset, which gives us still a good idea of what different models can show, and you could obviously assume where it shows snowfall accumulations there would be some sort of snow occurring there. And obviously, as we put this forward, you can see the European does kick a lot of that cool air out. You can't really see it well on this map, but you can see that's a 32-degree line, that red line. So you can see it's going pretty far towards the north compared to what we're seeing now, which is it's pretty far towards the south, and again, a lot of cold air towards the north. And again, there's that little clipper, which, by the way, a lot of the ensembles from the European are more more in the boat of showing a clipper potentially interacting with some sort of a moisture from the north, from the ocean, and then developing into a nor'easter, while the GFS potentially are more leaning towards the GFS models and its ensemble family towards a system maybe across the central United States more so. So that's slightly something I've picked up on, with the pattern, but still the inconsistency among them is very strong. Notice there's that European, it starts showing that system again further towards the east, similar to what the Canadian showed, interacting with that moisture further eastward, not really across the central United States. And again, you can see that as it pushes into the northeastern United States, interacts with cold air, lots of snow, potentially upstate areas, but eventually maybe even some of the coastal areas are picking up on some snow. Especially as this system potentially wraps up behind it. And notice into southeastern Canada, this pushes a lot of snow. Another concerning thing is, if there's going to be a lot of warm air, and a lot of that snow, those 66-inch amounts of snow, will start melting across the great lake belts, the lake effect belts, and that could lead to some flooding, or additional snow could pile on, which would, obviously not be good, as they would still be cleaning up from that event. And yeah, so you could see after that, we could also see some sort of a lake effect event there. But yeah, you can see each model is slightly different. I want to show you what the European, so again, the same model showed just 12 hours prior to this. You could see it showed again some sort of a clipper system, moisture from the south. You could see it maybe started showing a system trying to develop across the central United States, but similarly, decently enough to what it's doing now. It showed that system just kind of further eastward develop. But for the past 12 hours, I would say the European has been more consistent. But if you look at yesterday during the noontime hours, the European also pretty much showed nothing. So let me see if I can get this loaded for you. And I want to show you that each model here, there really isn't a winner here. A lot of them either show a system, then nothing, and the European, you can see, there we go. So yeah, this is what it showed compared to the most recent two model runs, which I just showed you, developing that big system across the northeast coast with that heavy rain and snow, compared to compared to yesterday's model run of the European, showed that clipper very far towards the north, never interacted with any moisture off the northeast coast, and it doesn't really develop into a storm system whatsoever. And yeah, so the European is you can see also very inconsistent. Now, we'll have to watch it very closely the next 12 to 24 hours for consistency, whether or not there are some signs, maybe the GFS, or sorry, the European and Canadian start kind of agreeing on that system that interacts more, or starts more as a clipper. It's pretty weak, interacts with that moisture, and then becomes obviously a big system. Or maybe we start seeing some of the models trend towards what the GFS ensembles are showing, which is, again, that system that initially is further, I guess, south, and not as far north as what the Canadian and European show. So it allows it to develop a bit earlier on, and then obviously it does still impact the Northeast, just maybe it's further north, so more rain and warm air gets in. That's also a very possible scenario, and we've seen both models kind of jumping back and forth on that. So let me now go back to the weathermodels.com and start showing you some of the ensembles. So, kind of many models that I could show you combined, or not necessarily combined, just individually, just so you get a good idea of what the spread is in terms of the idea for this system. So let's go to the precipitation type forecast. So this just kind of shows us the simulated amount of precip that could be falling within a few hour intervals at a given time, depending on which ensemble. And you can see there's 50 different individual models that make up the European kind of ensemble group. So I'm obviously not going to show you all 50, but I'll just click on through randomly and show you the different scenarios. So you can see some are like this, that really don't show that big of a system. It does, you can see it start interacting and developing into storm, but it's just off the viewing kind of area, and it's not really as much impactful as it could be. Now looking at another random model, let's see what this one shows. Okay, so it shows more moisture earlier on, shows bigger system developing earlier on across potentially more of the central United States, but eventually does, you can see, bring a lot of moisture into the Northeast, and potentially develops some snow on the northern side, still though relatively more of a rainmaker. Now let's click on another one. Let's click on P16. And again, just another ensemble. I'm not picking these on purpose. They're just random ones I'm choosing through. You can see this one keeps it more off the northeast coast, though it introduces some snow of significant potentially value across Boston, New Hampshire, or Massachusetts, I should say, Maine, into southeastern Canada. Though again, completely different from the other two I showed you. Let's move on to our fourth one. Let's click on P7. And let me show you this. Okay, so there's that clipper. You can see it's further towards the south and way further towards the west than the other ones I've showed you. So it allows itself maybe to interact a bit earlier with that moisture, produce some more aggressive accumulations further south. You can see Pennsylvania, more lower state New York, and then eventually you can see a lot of moisture does mix in. That would be obviously a very impactful and impressive system if that were to occur. That's just, one of the models that show it. Let's take a look at another one, P46. So we're back to some of the higher, I guess, numbered ones, 46 here. So again, this is a one that shows a system, again, pretty impactful one. And you can see it develops a lot of snow across upstate New York, again, or upstate New England and into southeastern Canada. But it's still slightly different from all the other ones I showed you. And then you can see it keeps the weather pattern pretty active moving forward. Let's take a look at P50, the last kind of the 50th ensemble here. So again, it shows a clipper that is more further towards the west, so it delivers maybe some lighter snow accumulations for the central kind of U.S. here, the western Great Lakes. But then it does end up showing a very nasty nor'easter, potentially a strong circulation, and more of the coastal areas getting slammed by this. So it shows a system and a snowstorm just way differently than the other models. And which one right now, I'm favoring? It's kind of a really almost impossible question to answer based on the consistency. It's more unlikely that we'll see something like just the one I showed you with the coastal nor'easter, and it's more likely we'll see a giant slug of moisture kind of just move towards the north. And exactly how that does happen is obviously up for question. But something of what the European operational was showing, which I showed you earlier, and what the Canadian. You can see this one does something even differently, introduces a lot of Arctic air, so this system never really fully materializes as the dry air kind of just pushes it out. Let's take a look at the control here from the European here. And let's take a look at how this plays out. And again, I'm just going to be showing just a few more here. You can see this one, again, kind of does what the other models were doing, just shows this giant slug of moisture moving in, eventually converting a lot of that rain into snow. That is definitely a possibility, though you can see this one's further closer towards the shore, so it doesn't impact southeastern Canada as much, more of just the northeast. Again, it's $1 million question that no one really knows how to answer right now, and if you're to look at the weather models, it's all over the place. So let's take a look at the eastern United States. East Coast here with the GFS. So this is now another group, right? So if you thought that was, confusing enough, which 50 of those are more correct than others, there's a whole different family here. And sometimes we have this where, one family, like the whole Europeans, do agree on something, but the GFS models don't. And then which family is more correct, right? I wish we had that problem, because right now we don't even know which individual model from the individual ensembles is correct. So let me not show you the snowfall. Let me show you the precipitation type so you can see the scope of this. It's a bit hard to see. Hopefully you can see though, as I well, you can see it's the eastern United States, and there's the green and blue indicating the rain and snow. And again, this is the Wednesday, Tuesday, Thursday time frame. So just start noticing if you could see some sort of a big system develop, and you can see that a lot of them do. You can see off of Thursday, but especially into Friday. So initially we do have a slug of moisture that moves off just in the East Coast. It seems pretty consistent that every single model does show that. Okay, so again, pretty consistent again up until this 150, 60 hour time frame where we start seeing that system get introduced, and this is where we start seeing a lot of disagreement again amongst the GFS ensemble. So notice some are showing a system further north. You can see, I don't know if you can see that on that one. Some are showing a system that has a lot of more snow on the backside of it. This is a bit kind of impossible to show you because of how small these things are, but you could see that as I generally put this through, you can see all of them show some sort of a big event going on across the eastern United States, except there's really even hard to find two that show it in a pretty similar way. Most of them have their own interpretation of this. So the odds are that there will be some sort of a winter storm. How does it play out? And will it even be a winter storm? Will it be maybe more of a rainmaker? Maybe it won't even form. That's kind of the big question here. But again, for now, I'm just warning you guys that come Thanksgiving, especially late week, there could be a big system, and you can see that a lot of models are showing it. So don't be surprised if you do end up seeing something like what the GFS or other models are showing. A massive system, a large snow swath, a lot of rain, or even more concerningly, what the potentially what the European model was showing, the European operational ones. So not the individual ensembles obviously had their own opinion, but if you were to take a look at the actual European model and United States, so let's go through these filters once more. Precipitation type, if you recall, this one showed an even more impressive system than GFS because of all the moisture that it just showed moving in up the northeast coast and converting to snow. So that would be obviously a very impressive system, to say the least. All right, yeah, but that's basically it. Just wanted to give you an update on that there's a big system, potentially moving in. Obviously, this thing will be moving into the northwest first, initially as that little piece of energy, but you can see that you can barely see when it passes through. It's not going to be anything too incredible. It's not going to be off of like a massive storm from the north and the west like we sometimes see. It's just going to be a little area of disturbance that's enough to bring up some of this moisture here and kick off kind of a chain reaction of a bigger event. Alright, so yeah, that's basically it. Again, let's see if we could refresh some of these snowfall amounts here. Maybe there's a higher one that just got reported in. I would doubt, yeah, I doubt it, but there we go. You can see 66, so same report there. But again, tomorrow we'll probably see some amounts that are, approaching 72 inches, which would be, I believe, 6 feet. So yeah, that would obviously be crazy. You can see, looking at the radar, we are continuously seeing a very, very well-defined band of snow that is now potentially starting to move towards more into Buffalo. So yeah, that's basically it, guys. Thank you so much for watching, and I will catch you all on the next episode. See ya.